Hello everyone, this is Vivek. Today I am going to discuss the next part of the semiconductor, in which the types of semiconductors here. One is intrinsic semiconductor, another one is extrinsic semiconductor. Intrinsic semiconductor, see, so the discussion concepts are intrinsic semiconductors and extrinsic semiconductors. Intrinsic semiconductors are nothing but these are the semiconductors which are chemically pure type of semiconductors and whose conductivity is very poor. So these kinds of semiconductors we can call it as intrinsic semiconductors. See here in the intrinsic semiconductor, yesterday I given the basic about the intrinsic semiconductors. Today we are going to explain. We are going to learn in depth. See, in the semiconductors, the molecules or atoms are arranged like this. That is, the tetravalent atoms. See, these are the atomic arrangement in the semiconductors. Each atom having 4 valence electrons. Each atom having 4 valence electrons. Each atom having 4 valence electrons and the pairing of electrons. Here, the sharing of pair of electrons. The 2 electrons share and form a covalent bond between the 2 atoms. See, between these 2 atoms there are 2 electrons and due to sharing of these 2 electrons there is a covalent bond. Again, due to these 2 electrons one more covalent bond formed. Again here one more covalent bond is formed like this. Due to sharing of pair of electrons, the covalent bond between the neighboring atoms form like this. Say, this is an arrangement of the semiconducting materials. The atomic arrangement of the intrinsic semiconducting materials. Here we consider this is a germanium atom. So in the intrinsic semiconductors which are chemically pure, nothing but there is no foreign atoms present inside the semiconductor. All the crystals they are germanium. If you consider a germanium semiconductor, then all the atoms are germanium. There is no foreign atoms are present inside the material. So this is the concept of atomic arrangement of the intrinsic semiconductor. Here intrinsic semiconductors are at a 0 temperature, at 0 Kelvin temperature. There is a semiconductor which is acts like a insulator, because here there is no free electrons are available to conduct. If the conduction process takes place where the free electrons are moving, we know the definition of the conduction process. That is movement of the charged particles. That gives a conduction. Here there is no free electrons are available to conduct. It is at 0 Kelvin. With this is acts like a insulator. Say at a higher temperature, nothing but it is a more than 0 Kelvin. So as temperature increases, atoms inside the semiconductor which absorbs the energy. Once energy is absorbed by the atoms inside the material starts to vibrating about its main position. Due to vibration, what happens here? The bonds between the atoms will be break down. See here, as the thermal energy increases, thermal energy nothing but a temperature. As the temperature increases, nothing but thermal energy increases, the atoms that starts to vibrate about the main position. Due to vibration, what happens here? The bond will be breakdown. Once the covalent bond is break down, there are two free electrons are available, and these two free electrons absorbs the energy and easily excited to the higher energy level. Then the molecules, in the molecules, electrons are excited from valence band to conduction band. That process we can call it as conduction. See here at 0 Kelvin, this semiconductor, nothing but intrinsic semiconductor is acts like a insulator. As the temperature increases, then this is acts like a conductor. That's why this semiconductor we can call it as semiconductor. This electrical properties lies between conductor as well as insulator. Sometimes it is works like an insulator, sometimes it is works like a conductor. This is what we can call as semiconductor. Okay, so then here once these electrons absorbs the thermal energy, that is excited to valence band to conduction band. Then see here, this is energy level. This is an energy level. So that for example, so this is valence band. And this one is conduction band. The so many electrons are available. Actually, initially there is no free electrons are available to excite. But as thermal energy increases, the free electrons are created. So those free electrons are available here in the valence band. And the conduction band, in the conduction band, there is no electrons are available. Once these electrons get absorbs the energy, that is excited to the conduction band. See here, the movement of the electron. Due to movement of the electron, we know that movement of electron we can call it as a current. The rate of flow of charges here, electron is a charge. Hence, HE be the, IE be the current that is produced due to movement of the electron. And so here this is the in case of intrinsic semiconductor. This is the conduction process takes place in the intrinsic semiconductor. At 0 Kelvin it is acts like a insulator. At higher temperature this is acts like a conductor. This is about the concept of intrinsic semiconductor. Now we will go to extrinsic semiconductor. Extrinsic semiconductors are nothing but we already learned that about the intrinsic semiconductor. In the intrinsic semiconductor, semiconductors are chemically pure and whose conductivity is poor. But in case of extrinsic semiconductor, see, extrinsic semiconductor is the improved form of the intrinsic semiconductor. Then whose conductivity is high. See how means intrinsic semiconductor, in the intrinsic semiconductor the material is completely pure, there is no foreign atoms are present. But here to increase the conductivity process, the intrinsic semiconductor having the poor conductivity, we need to increase its conductivity now. To increase its conductivity, then so we need to dope some foreign materials. We need to add some foreign material to this semiconductor. This intrinsic semiconductor which requires some foreign materials to increase its conductivity. Then now it is called as extrinsic semiconductor. See, extrinsic semiconductors are the semiconductors which are chemically impure type of semiconductor, whose conductivity is high. To increase its conductivity, we are going to dope something. Doping. So what is that doping? I just told that doping. That doping nothing but it is the process of addition of foreign atoms to the intrinsic semiconductor to increase its conductivity. That process of adding the impurity which is called as doping process. Then material, which material we are going to add? that material we can call it as dopant or doping agent. Then to increase its conductivity, we need to dope something. That is something foreign atoms. That is what we can call it as extrinsic semiconductor. See here, the intrinsic semiconductor example germanium, silicon like that. To that silicon, germanium, we need to add some impurities like phosphorus, arsenic, indium, gallium, aluminium like that. So if we add those impurities which are trivalent and pentavalent impurities, then its conductivity increases. See one more thing, in the intrinsic semiconductor, number of electron is equal to number of holes. I just already told that in the intrinsic semiconductor. Then what about holes here? Holes. See, in the intrinsic semiconductor, once the temperature is high, the bond will be break down. If bond is broken, then free electrons are available. Due to thermal energy, these electrons are jumped. That is, movement takes place. So that transfer to one to another. Then if the electron is excited, then the hole is created here. See here. If electron is jumped to the higher energy level and that transfer to the another place, and there is a vacancy is created at this position. This vacancy we can call it as holes. This hole is a positively charged. Then this is an electron which is negatively charged one. Because of the vacancy created at the place of electron, this is a positively charged one and this is called as holes. These holes in the intrinsic semiconductor, number of electrons and the number of holes are equal. Number of electrons and number of holes are equal in number. This is about the intrinsic. And in case of extrinsic, how it works? What it exactly in case of extrinsic semiconductor? See, on the basis of doping agent, again these extrinsic semiconductors are divided into two. One is a N-type semiconductor, another one is P-type semiconductor. One is N-type semiconductor, another one is P-type semiconductor. N-type semiconductor, now we are going to discuss N-type semiconductor. In the extrinsic semiconductor, just I told that the doping of impurities to the intrinsic semiconductor, we can call it as extrinsic semiconductor, in which N-type means the pentavalent impurity. Penta means 5. 5 valence electron. That means 5 valence electron. If a pentavalent impurity is added to this intrinsic semiconductor, then this type of semiconductor we can call it as N-type semiconductor. Why it is called as N-type only means, now I will explain that. See here, initially it is a pure type of semiconductor, that is intrinsic semiconductor. Once the doping process complete, just I told that the doping means process of addition of impurity. Now I am going to add that phosphorus. So phosphorus is a pentavalent impurity. See, phosphorus is pentavalent impurity. Now I am going to add, I am going to dope. If one atom in a crystal lattice of germanium. See here, these are the germanium atoms initially in the intrinsic semiconductor. I am taking example. In the germanium atom, now I am going to replace this germanium atom by the phosphorus. PH, phosphorus. See, now this is the foreign atom having 5 valence electrons. One is here, second, third, fourth, one is extra electron is here. And these 4 electrons, 1, 2, 3, 4, they are using bonding, covalent bonding. This electron is sharing with this and which forms a covalent. And this is with this and form covalent and covalent and covalent. But one extra electron is available. This is the free electron. If this free electron absorbs a small amount of energy, that is get excited to the conduction band. From valence band to conduction band, easily excited with a small amount of energy. Then, so this is why the conduction process is more in case of extrinsic semiconductor. And note, see here, the additional electron is available here, like that. So we are going to add these electrons, we are going to add these impurities like a phosphorus, gallium, indium. These are the impurities, and the impurities is added in the proper manner with a control order in the range of, that is 1 in 10 to the power 6 atoms. The doping process takes place in the order of 1 in 10 to the power 6 atoms. Out of 10 to the power 6 atom, we are going to add 1 foreign atom. Like that, if many number of foreign atoms are present in a material, then many number of free electrons are available. If the addition of impurities is more, then free electrons are more. Then as the temperature increases, its conductivity increases because these free electrons get excited easily. That's why the conductivity can be increased by doping process in the extrinsic semiconductor. But what about in the intrinsic semiconductor? In the intrinsic semiconductor, how can we increase the conductivity? There is no doping at all in the intrinsic semiconductor. Then how can we increase its conductivity? The conductivity of the intrinsic semiconductor, that is, increases with increase in temperature. As the temperature increases, bond will break down, then free electrons are available more. Then in intrinsic semiconductor, conductivity increases with increase in temperature. In extrinsic semiconductor, so the conductivity increases with doping process, addition of impurities. Then here n number of free electrons are available. Then see here, in the n type of semiconductor, electrons are the majority charge carriers, holes are minority charge carriers here, which are available very less in number, but electrons are more in number. See, electrons are the negative type of charge. That's why these kinds of extrinsic semiconductor we can call it as N type of semiconductor. In the N type of semiconductor, see, once again I am explaining, the pentavalent impurities is added to the intrinsic semiconductor. Then as pentavalent impurities added, then so the free electrons are available more. If a small amount of thermal energy is supplied, then this electron get easily excited and conduction process continues. This is about the extrinsic semiconductor. The similarities, the difference between these intrinsic semiconductor and extrinsic semiconductor. In the extrinsic semiconductor, conductivity of extrinsic semiconductor is greater than the conductivity of intrinsic semiconductor. That is the major difference. Their conductivity increases with increase in temperature in case of intrinsic. Here conductivity increases with adding the dopant. Then this is about the N type of semiconductor. P type semiconductor and its explanation we'll discuss in the next class. Thank you.